Screw threads and thread terminology. This module will give you a general introduction into the world of screw threads. It will define threads and explain the meaning of some of the commonly used terms and some of the ones not so common. For want of a nail, a kingdom was lost. That same sentiment could very well apply to industry if a force were discovered that would remove all the threads on all the bolts and nuts used today. The quotation might then read, "For want of a bolt, an industrial empire was lost." Screw threads are all around us. So much so, in fact, that we pay no attention to their numbers and varieties. What is a screw thread anyway? In engineering jargon, it is a helical ridge of uniform section which is formed on the inside or outside of a cylinder or a cone. So much for jargon, which, by the way, is a special language used by a trade or profession which often confuses the outsider because he doesn't understand what is being said. In simpler terms, a screw thread is a continuous spiral line of grooves and ridges turned on the outside or inside of a cylindrical object or cone. Screw threads have been serving mankind since the time Archimedes invented the first screw for raising water. They have become quite versatile since. Example? Well, they're used for fastening devices such as bolts, nuts, screws, studs, and so on. They're also used in another way to transmit motion. Watch the lead screw on your lathe to see how it moves the carriage back and forth. Borrow a micrometer and look at it. There is another application where it's used in a measuring device. If you're unfortunate enough to have a flat tire in the near future, watch how the screw jack operates. Here's an example of a thread application where it's used to lift heavy objects. It would be impractical and unnecessary to describe all of the different kinds of threads used in industry throughout the world. But there are a few of the more common ones you should know about, 7 to be exact. One of the 7 is the American National Thread. The American National Thread has 4 subheads: National Coarse, NC; National Fine, NF; National Special, NS; and National Pipe Thread, NPT. The American National Acme Thread is another of the common thread types, and so is the Brown and Sharp Worm Thread. Here is one called simply the Square Thread. It is gradually being replaced by the Acme Thread. The one shown with the Square Thread is an English contribution called the British Standard Whitworth Thread. Notice the radii on the bottom and top of the threads. The International Metric Thread is popular on the European continent. A lot of them are used here in North America too, on instruments and spark plugs. There are no radii on these. During World War II, the necessary intermingling of war material made it painfully clear how advantageous it would be to have standardized threads in order to interchange the various parts of the mechanized equipment used in the life and death effort by the Allies. As a result of the wartime experience, the United States, Canada, and Great Britain agreed to develop a standardized thread. This was in 1948. The thread has become known as the Unified Thread and is abbreviated as UN. The bottom of the UN has a radius, but the top is square cut. The fit of a nut and bolt, when they're assembled, depends on the type of thread they were manufactured with. The fit can be very close, medium free, or free fit. It will be the result of the allowance. More about that later. Numbers are assigned to the description of the way the male and female threads fit. Number 3 is very close, 2 is medium free, and 1 is free or loose. This range of tightness or looseness is appropriately called the fit. When designating fit, the number is often followed by either the letter A or the letter B. A shows that the thread is external or male thread, while B means an internal or female thread. Here's another word for your jargon: allowance. The allowance is the difference in size between threads on the parts that are to be assembled, in this case the nut and the bolt. The difference is, of course, intentional. It is the allowance that determines the fit of the finished parts. If all the parts in an automobile had to be manufactured exactly to dimension, with no allowances made for the slightest errors, the cost would be so high that only the very rich could buy a car. To avoid this problem, engineers permit a certain amount of variation in the machining of parts. This is called a tolerance, and it applies to making threads also. An item that can be made a few thousandths either smaller or larger than the specs is said to have a plus or minus tolerance known as bilateral tolerance. If the item can be too large but not too small, or vice versa, then it is said to have a unilateral tolerance. Don't confuse the term allowance with the term tolerance. They're not the same. More jargon. The proper term for a thread that is cut on a bolt is an external thread, but get used to another term too. You'll hear it referred to as a male thread. The correct term for threads in a nut is internal thread. In jargonese, it's a female thread. In the shop, they both mean the same thing. In this drawing of an external or male thread, there is only one part identified so far. The part shown is called the major diameter. You can easily see why. It's the largest diameter of the threaded bolt. In shop jargon, they often refer to it as the OD of the bolt. This, of course, means outside diameter. Here's the same bolt again. If you guessed that because there was a major diameter, there had to be a minor diameter, you're right. This diameter used to be called the root diameter. This one is not so easy. It's another diameter, of course, but it needs some explaining. Pitch diameter looks as though it is the difference between the major and minor diameters on this drawing. That would be a good guess, but not right. Try this. Find the point on the thread where the width of the thread is the same as the width of the groove. Mark the spot, then do the same thing on the other side of the bolt. When you have made the mark on each side of the bolt, connect the two marks with a perpendicular line. Measure that line. The measurement you have just taken is the pitch diameter of the threads. This was easy to do because we were working with a drawing. On a real bolt, the pitch diameter is an imaginary line that meets this criteria. Now that you know pitch diameter, another term, pitch, is easy. As you can see, it's the distance from peak to peak. Speaking of peaks, that's the wrong name even though it seems to fit. The correct name is crest, and that fits also. Screw a nut on a bolt until the end of the bolt is flush with the outside edge of the nut. Next, turn the nut exactly 1 revolution. Now measure the amount of thread sticking out. The amount you have just measured is called the lead, which is the distance the thread advances along the axis of the bolt. You have learned another thread term. You've already had a hint on what a crest is. To be more specific, it's the highest point where the sides of the thread join. In other words, it's the surface from which the major diameter is measured on an external thread. Knowing what the crest is makes finding the root that much easier. It's at the bottom of the thread wall. If you were looking between two mountain peaks, the root would be the bottom of the canyon or the floor of it. This whole side of the thread wall that connects the crest and the root is called the flank. Drop an imaginary plumb line from the root of these threads to the crest. The length of that imaginary line is known as the depth of the thread. Depth, to define it, is the perpendicular distance from the crest to the root. Notice how the flanks of the threads lean away from the root and each other as they go toward the crest. As you can see, they create an angle by doing this. The angle they make is called the thread angle. Look very closely at these threads. See how they slant? Well, that slant is an angle. A slight one perhaps, but still an angle. That angle is called the helix angle. Here are two thread patterns. One of them is the one you just studied. The other, at a casual glance, looks identical to it. But look again. See how the threads slant at a different angle? The helix angle leans the opposite way from the first bolt. That's how a left-hand thread looks. The other bolt is, of course, a right-hand thread. So much for helix angles and how you can tell a right and left-hand thread by visual inspection. If you hear the term lead angle used around your shop, don't be upset or confused. They mean the same thing. On coarse threads, the helix angle will be greater than on a fine thread. When the term number of threads is used, it always means how many threads that can be counted in a 1-inch length. Counting of the threads is done by counting either the crests or the roots. In summary, a blueprint or working drawing will show the requirements for a bolt or nut as a series of numbers and letters. Each item is necessary to obtain the finished product and is easily determined once the information in this module is understood. The external threads on this bolt look a bit different with all the parts of it identified, but it's still the same bolt. The how and why for specific threads and their selection for different mechanical functions are too extensive for general terminology. For the time, they are better left to be learned as experience is expanded.